Hey guys, welcome back to part 2 of this 1998 Suzuki RM250 build. Today we're going to be vapor blasting everything as well as recoating the inner clutch cover and the ignition cover. I'm going to show you the before video of all the parts and kind of talk about what's going on with those. And then right after that we're going to go ahead and get right into the vapor blasting. Here's a quick look at what all we're going to be vapor blasting. The cylinder head here looks to be in pretty rough condition, but it should turn out pretty nice when we're done cleaning it. The crankcases overall are in pretty good shape. They should clean up fairly well, I think. We're going to be vapor blasting both the inside and the outside of them. As you can kind of see in this video, we've sort of pre-cleaned a few of these parts. All of them will be going through our pre-clean process before it goes into the cabinet. The ignition cover will be sandblasted and resprayed. We'll also be doing this to the inner clutch cover. These pieces are both made out of magnesium, and honestly they just don't accept the vapor blasting process very well. Normally we would Cerakote these type of pieces, but unfortunately it just isn't in the customer's budget for this particular build. The clutch cover, we're just going to clean up the inside and vapor blast it. It looks like there's a couple gouges here on the outside. It looks like the Kickstarter might have contacted these areas, and there's actually a crack that goes all the way through. It is pretty small, but we're just going to be doing the best we can to repair this because again it's just not in the customer's budget to replace this. Okay, to start things off, we're going to go ahead and load one of the crankcases into the vapor blasting machine. I'm probably only going to show a few minutes of some footage in the cabinet because otherwise it's just going to be way too repetitive. We're going to go ahead and load the inner clutch cover into the sandblast cabinet and prepare it for paint. We're also going to be doing the same thing with the ignition cover. Now we've got everything cleaned up, so I'm going to show you a close-up of how all these parts turned out. I think they turned out really nice. First up is the clutch cover. This is the one that we had to repair. We just simply added a little bit of JB weld to fix that hole in the cover. I think it'll be just fine. It really shouldn't cause any issues. The inner clutch cover, we just went ahead and sandblasted it and resprayed as you saw earlier. The inside, we did end up vapor blasting it, but as you can see, magnesium likes to corrode, so it will kind of leave like a chalky finish. And same thing with the ignition cover, we just went ahead and sandblasted and resprayed it. You can see there's a little bit of a damage area down there at the bottom part. Again, we just went ahead and JB welded it and fixed it. This really wasn't revealed until after we sandblasted and we could see how corroded the magnesium is. We were able to clean up this Kickstarter very well. Everything came out very nice on it. It wasn't noted until really later how bad this Kickstarter is really worn past its limit. As you can see here, it kind of extends beyond where it should set, and it's kind of moved the material a little bit out of the way. I believe that's what damaged the clutch cover. This may have to be replaced. The shifter, it also turned out very well. So if we go up here and look at the case saver, it turned out very well from the vapor blaster. The plastic did have a little bit of spray paint on it, and it was able to remove that, and the aluminum piece turned out very well. If we take a look at the cylinder head, it was able to be cleaned up pretty well. You can see there's a little bit of corrosion here where the water pipe comes in. I don't really think it's going to be a problem. It's just one of those things where it just sat with water on it and it just started to corrode it. If we go over to the power valve covers, they also turned out very well. They're pretty dang clean compared to what they were. I mean, all of this stuff was covered in some pretty thick carbon, so it did take us a while to clean all of this. Even the inside of the covers turned out extremely well. If you remember from the teardown video, this cover was just filled with bits of carbon all over it. It was a lot of thick hardened carbon. If we flip these little power valve covers over, you can also see how very clean that they are. They turned out extremely well. So this is the main power valve piece. Again, it was covered in a pretty thick carbon. It was able to be cleaned actually relatively easy. Moving on to the crankcases, this is what they look like now. This is after about 2 to 3 hours in the vapor blasting unit. We was able to clean both the inside and the outside very, very well. I really think the video kind of just speaks for itself just to show how clean everything really is. So if we put the crankcases together, here's what it's basically going to look like when everything's all assembled. As you can see, everything is just immaculately clean. I really like showing close-up of these parts so you can really get an idea of just how clean everything is. The bad thing about pictures is it really just doesn't show that kind of detail. Here I've got all the rest of the small parts bagged up and labeled. I didn't show us cleaning any of these parts because honestly it's pretty boring and we really didn't vapor blast but a few parts. I'll go into a little bit more detail when we go to the assembly video. One last thing we need to address are these very badly stripped out threads for this drain plug hole. It's normally an M12 with a 1.25 pitch bolt that goes through this. Now normally we would just tap this up to a 1/2 inch 20, but unfortunately it's just too far gone to do that. So we're going to be installing what's called a time cert. What's going to make this repair even more difficult is this side port here. We're going to have to come in with a drill bit and bore that back out as well. To make this repair, we're going to be using this time cert kit. What a time cert basically is, for those of you that don't know, is it's a bushing system. So you basically take a drill bit, bore out the metal, and then you're going to take their tap and recut threads, and then the bushing just threads in there. So the bushing is going to have both external and internal threads, and the internal threads are going to be what you're going to need. It's a pretty easy to use system overall. Everything comes in the kit as shown here with the exception of this guide here. You do have to buy this separate in certain kits. The nice thing about having this guide is you're able to hold the guide against the material that you're cutting the new threads into. And what it allows you to do is cut nice and straight threads so that way you're not cutting at an angle. The bushings supplied in this particular kit were 15 millimeters long. I ordered a few different sizes because I wasn't sure what I'd need. You can pretty much get these in any size that you need though, and they're pretty cheap, like $2-3 a piece. I'm going to show you a quick walkthrough of what we're going to be doing on this repair. Here's the instructions that they supply in every kit. So you're going to get a drill, a counterbore, a tap, a driver, and then of course the inserts. You're going to start out by drilling the old threads out. And then you're going to take their counterbore tool, which is going to cut a nice shoulder for the insert to seat on. And then we're going to be tapping the new threads into the bored out hole with their tap supplied. And then once you've got the threads cut out, you can thread the bushing onto the driver tool. It's important to put oil on the driver tool, and then you're just going to install the bushing. It's pretty easy really to do, it's just you got to be very careful. So with that said, we're going to go ahead and show you how this repair is done. We're going to be using red Loctite 272 high heat on this bushing. It's good for up to 450 degrees. I didn't show it, but always make sure that you have oil on your driver tool for installing this bushing. Because when you go to install this bushing, the bottom part of the threads are not formed yet. So when the tool actually passes all the way through the bushing, it forms the threads, which locks the insert into place. Don't be afraid to liberally apply Loctite onto the bushing. It just helps ensure that the bushing won't ever spin or cause any problems. Hey guys, here's the final result of our TimeCert installation. As you can see, there's some nice new threads in there. I'm going to take the factory drain plug here and go ahead and thread it in there so you can see just how smooth it installs. No kind of hang up or anything like that. So there it is, bottomed out right there. You can see it's all the way through. Looks like a nice clean install. Make mention that we did trim down this insert just a little bit. Now you're really not supposed to do this, and TimeCert doesn't recommend that you do this because the bottom threads are actually what lock the insert in place when you pass our installation tool through it. With the amount of Loctite we have on this, I really don't think it's going to be an issue. So we just took a small Dremel tool with the sander on it and just sanded it down to the case to try to blend everything in really nicely. Then after that was done, I went ahead and loaded it into the vapor blaster to kind of make everything look more even. On the other side of the case, we also had to bore a small hole for the oil to feed through. So if you look closely, you can see where our hole's through here. The reason why there's a hole here is so that the other side of the case can drain all the oil out. It was done like that from the factory, so we just went ahead and did the same thing. The really nice thing about these time certs is they look just like a factory thread. So if you look at one of these factory threads on one of these 6mm holes, you can see how it's got kind of like a shoulder there. If we go down here to our time cert, it really looks pretty much the exact same. I do need to mention though, the time cert kits, they are pretty expensive, and for this particular kit it was 105 bucks, but that's because you're buying all the bits and tooling and all of that. The nice thing is they are all made in USA, and if you do have to have any more inserts, like I mentioned earlier in the video, I think they're like $2 or $3 a piece, so they're definitely not that expensive. Okay, so that'll do it for part 2 of this video series. I hope you enjoyed the video. If you did, please give us a like and consider subscribing to our YouTube channel. You can also find us on Instagram at Motoblasters LLC. In part 3 of this series, we're going to be assembling the engine, so make sure you keep a lookout for that video. So until next time, take care guys, and I'll see you in the next video.